Today we're going to talk about feedback loops, and the goal of this video is to explain how an organism maintains homeostasis through positive and negative feedback loops. First, what is a negative feedback loop? A negative feedback loop is a feedback system that opposes change to a set value in the organism. So this graph will show you how a change to a set value is opposed. So there's some optimum set point. In the last video, I gave you examples like your body temperature is supposed to be 98.6, your blood pressure is supposed to be 120/80, and so on. These are like optimum set points. And then the internal environment changes. A corrective mechanism is then activated to try and restore the body to its set point. And once that mechanism is activated, the body ends up returning to the set point. If it goes too far, and so it swings in the opposite direction, then the corrective mechanism is activated again and returns you to the set point. So the key there is there's some set point, and when you move away from the set point, there's a mechanism that tries to bring it back, to restore you to the set value. So in this case, change is opposed. That's what happens in a negative feedback loop. Change to the set value is opposed. Let me give you some examples here of negative feedback loops in the body. So your body maintains constant temperature through a negative feedback loop, actually. So in a previous video, I told you there are three components of a feedback loop. There's a sensor, a control center, and an effector. In this case, when your body's controlling its internal temperature, the sensor are your nerve endings. These detect a change in the temperature, and they send a signal to the control center. So if it's really, really cold, you might notice you get goosebumps. That's an indication that your nerve endings are detecting the change in temperature. So the nerve endings send a signal to the control center, which in this case is the brain. So when that signal arrives, the brain receives that message and then sends a message to your muscles. The muscles are the effector in this case. And when your muscles receive the signal from the brain, they begin to shiver. And this produces heat. When your body shakes, it produces heat, and that heat is what restores your internal body temperature to its set point. So this is an example of a negative feedback loop in the body. Now, there are also positive feedback loops. A positive feedback loop is the opposite of a negative feedback loop. Rather than try to restore you to the set value, it only amplifies the change or increases the change to the set value. So you get further and further away from whatever the set value is. Now, a positive feedback loop is much less common because it can become really unstable if it's prolonged, if it goes on for a long period of time. An example of a positive feedback loop in the body is birth. Birth has the following steps. So the baby pushes. I'm going to start at the top of this little cycle in the picture. The baby pushes against the cervix, and this causes the cervix to stretch. But the stretching of the cervix, I'll keep my pointer on it. The stretching of the cervix causes nerve impulses to be sent to the brain. When those nerve impulses are received by the brain then stimulates what's called the posterior pituitary to release oxytocin. So the key there is the stretching of the cervix sends this impulse to the brain, when the impulse reaches the brain tells the body to start making oxytocin. But now go to the green. What does oxytocin do? Oxytocin causes the smooth muscle lining in the uterus to contract, to squeeze. And you can see how this becomes a loop. As the baby pushes against the cervix, the signal sent to the brain to make oxytocin. The oxytocin squeezes the baby even more, so the baby starts pushing even more against the cervix. And you can see how this is going to continue to loop. And this will go on until the baby is out of the cervix. Once the baby's delivered, then there's no more pushing on the cervix, and so the cycle can be broken. But this cycle won't stop until whatever's inside that cervix is pushed out. So this is an example of a positive feedback loop.